highlighting in 3 different colors, so if you want to prepare that. Anybody? 3 different colors? Alright, so looking at a normal distribution. So distributions of mileages of different sample sizes of cars are shown below. As the sample size increases, the distribution becomes more and more symmetrical and resembles the curve at the right due to the law of large numbers. Okay, so if you're looking at each of these graphs, okay, so you have n equals 100, that's how many cars they're looking at. This is what it looks like. N equals 10,000, so you're getting more and more numbers of cars. It looks more normal curved. And n to the entire population, you do end up with this nice normal curve there. Okay? So the curve at the right is a normal distribution. Okay, it is a normal distribution. A continuous, symmetric, bell-shaped distribution of a random variable. Okay? It is the most common continuous probability distribution. The characteristics of the normal distribution are as follows. Okay, so the graph of the curve is continuous, bell-shaped, and symmetric with respect to the mean. Okay, so it has to be symmetric with respect to the mean. So your mean is in the center then. The mean, median, and mode are equal and located at the center. Okay, so these are equal and in the center of that graph. The curve approaches but never touches the x-axis. Okay, it never touches the x-axis. It approaches it, so it is continuous. And the total area under the curve has to be equal to 1 or 100%. Okay, so we've been doing probability. Your probability has to equal 1 or 100%. So the area under the normal curve represents the amount of data within a certain interval, or the probability that a random data value falls within that interval. The empirical rule can be used to determine the area under the normal curve at specific intervals. So, in a normal distribution with mean, mu, and standard deviation, sigma, okay, approximately 68%, so I'm going to use separate colors, 68% of the data fall within 1 sigma of the mean. Okay, so 1 sigma of the mean, that is 68%. So that's this section right here of your normal curve. Okay, so each of these smaller sections is 34%. This is your mean in the center. Okay, your mean minus 1 standard deviation is this part. Your mean plus 1 standard deviation is this part. That makes up that 68%. Okay, then we have approximately 95%. Okay, 95% of the data fall within 2 sigma of the mean. Okay, so going from your mean, you subtract 2 times the standard deviation to get that part. And to get the other part, you add 2 times the standard deviation. So it includes that entire quantity. So that means it includes this 68% and that extra 13.5 on both sides. Okay, then we also have 99.7% falls within 3 standard deviations of the mean. Okay, so that's all the way around here. That's 99.7%. Okay, after this point, okay, if you notice, if you add all of these percents together, it doesn't equal 100, right? So beyond that, This one is 0.015%. Okay, so this quantity right here is 2.35% between these and between these. So after that point and after this point, you have 0.15%. Go find Mr. K.
I did already.
Okay.
Or you found me.
All right, so we're going to use this normal distribution just to answer questions when we're given the means and standard deviations of problems. So our first example, we have a normal distribution has a mean of 45.1 and a standard deviation of 9.6. So for letter A, we want to find the values that represent the middle 99.7% of the distribution. So that would be these points in our graph. So I have our graph off to the right here. We're given our mean. Our mean is that middle line right there. So that's going to be 45.1. Now we're given the standard deviation. To find the next pieces of it, to the right, I'm going to take 45.1 and add 9.6 to get this one. Okay, so if I add 9.6, 54.7, okay, to that 54.7, I'm going to add 9.6 to get the next piece. Okay, so that's 64.3. And then to get that last piece again, add 9.6 to the 64.3. And that's 73.9. Going back, so we can go to the left, start at 45.1, subtract 1 standard deviation of 9.6 from that. That's 35.5. Subtract 9.6 from your 35.5 to get the next one. That's 25.9. And then the last one, subtract 9.6 from that to get 16.3. All right, so in letter A, we want to find the values that represent that middle 99.7%. So 99.7 is that third standard deviation away, right? So we have our mean, we have 1 standard deviation, 2, and then 3. So that's this piece to this piece. So we just have to write out that range. So for letter A, our range would be between 16.3 and 73.9. So I can say my x values are greater than 16.3 and less than 73.9. So they're between those two values for that 99.7%. Okay, then letter B, we're going to use our graph here again. So it says what percent of the data will be greater than 54.7. So 54.7 is this one right here. And we need the percentage that's greater than that. So this piece is 13.5%, right? Okay, so up here, that was 13.5. Our next piece, this one, is 2.35. And then our last piece, that remaining percent, is 0.15%. So to get the percent that's greater, you just need to add those three pieces together. So we'll take 13.5 plus 2.35 plus 0.15. To get 16%. So 16% of the data will be greater than 54.7. Does that make sense?
No,
Which part?
no, I'm kidding.
Okay. Don't say that. Are you good? All right. And we're going to do some more examples. Do we have it all down? All right. So on the back, number 2, we have a normal distribution has a mean of 8.2 and standard deviation of 1.3. So our mean, standard deviation. So again, we're going to use the graph at the right, and we're going to label it. So our mean is that center point, that is 8.2. We're going to use our standard deviation to find our remaining values. So to the right, add, to the left, subtract. So 8.2 plus 1.3 is 9.5, then 10.8, then 12.1. To the left, we have 6.9, 5.6, and 4.3. Okay, so for letter A, we want to find the range of values that represent 95% of the distribution. So 95% is your 2 standard deviations away from the mean on both sides. So here we have 1 and 2. So that would be these values here. Okay, that's your 95%. So I could write out that my random variable x has to be greater than 5.6 and less than 10.8. So it has to be between those 2 values for that 95%. Okay, and then letter B, what percent of the data will be less than 4.3? So 4.3 is here, and we're finding less than, so which way should I go? Left. Okay, so this is 34%, right? This one's 13.5. This one is 2.35. What's the last one? 0.15. Okay, so I can write 0.15% of the data will be less than 4.3. Okay, questions on 2? Easy enough to read the distribution and the percentages? Okay, then number 3 is slightly different. Okay, so this one we're actually given what the distribution is talking about. So this one says students counted the number of candies in 100 small packages. Okay, so you have 100 total packages. They found that the number of candies per package was normally distributed with a mean of 23 and a standard deviation of 1 piece. Okay, so our standard deviation is 1, our mean is 23. So it says about how many packages have between 22 and 24 candies. So we're going to write out our normal distribution curve, just like we were before, with our mean of 23. Where does that go? In the middle. And our standard deviation of 1. So to the right, we're going to add 1 each time. This one would be 24, 25, and 26. And to the left, we'll subtract 1 each time. So 22, 21, and 20. So since we are looking for how many packages are between 22 and 24, right? How many packages did they look at? Total. How many total packages did they look at? 100, right? So this range that they're asking for, what is this range right here in your normal distribution curve? What percentage? 68%, right? So between those, that's 68%. What's 68% as a decimal? Okay, so I'm going to take the probability, which is 0.68, and I'm going to multiply by the total packages they looked at. So 100. So you do happen to get 68 packages. Now that won't be the case each time. I know for a fact on your assignment that it'll say out of like 412 packages. So instead of 100, you'd multiply by 412 with that percent to get about how many packages there would be. Does that make sense? Yeah? Okay, then using this same normal distribution curve, we're going to do letter B. So what is the probability that a package selected at random has more than 25 candies? So I'm going to locate 25, my curve, and it's more than, so we're going to go to the right. So this section is what percent of my curve? 2.35. Okay, and then my beyond section here is 0.15. So I'm going to add those together. So this would be about 2.5% of your packages would have 25 candies or more. Okay, so I can write it as a percent. If you wanted to write it as a decimal, you could. So you'd say 0.025 if you wanted to do that type of probability. Okay, questions on number 3? All right, I want you to try number 4. It's similar to number 3, so read through it. Find your mean and standard deviation, label your normal distribution, and then answer A and B.
I'm waiting for how long this question. Trying to. Not from you.
I'm going to do some other questions.
You do. What from
Prom theme. Time to pick the prom theme.
I was so stupid last year. It was so dumb. It was literally so dumb. I was there for like a half hour.
No, they had the decorator from last year come in like a day before it was supposed to happen. Yeah, it was the certain teacher or
Want to. Why does it even
No,
That's because it's just for juniors.
if they did, they did really bad job.
Did you look for free?
Oh, that's always gonna be like.
Gatsby.
Like if it was between 14 and
Island
16.
Getaway.
It would have been 95%.
Are you supposed to like pick your dress depending on the theme or something?
No, don't worry
why
about it.
Why does it matter?
It's always gonna be like
It's for decorations, like what type of
It's literally
decoration.
doesn't matter.
Yeah.
I feel like the eye look
They could have done way better for prom thing last year.
Yeah, that was literally so
Because it
bad.
was a masquerade, right?
Yeah.
My junior prom theme was masquerade, and we actually wore masks.
Literally 2 people wore masks.
Well, and they had masks on our tables and stuff, and like it was all like, I don't know, dark, I guess you could say.
Yeah, it would have been a lot better.
No, I just picked random thing. I didn't.
We had a photo booth that popped out pictures and stuff.
Our
We
photos
had
were
that
fun.
we had that at West. Over there at Oshkosh West, we had the photo booth, or we like took photos and it got to you.
That was the best, and they had like props on the table and stuff.
Yeah.
You got a photo booth out here too?
Yeah, but
Did you?
Yeah.
I don't remember that. I was there, and I don't
I
remember
was saying, I
that.
thought you were the person checking
I was.
everyone in and out.
I was there.
There was a photo
It was
booth.
fine.
Yeah, it was like when you walked in straight to the left.
Yeah.
Oh yeah, there was. I remember that now.
Yeah. I just remember getting there and I was like, this is so stupid.
Okay, so looking at this problem here, we have a mean of 38, standard deviation of 12. So your middle number should be 38. Okay, add 12 each time. I have 50, 62, and 74. That's a 7. To the left, 26, 14, and 2. So about how many members have between 26 and 50 friends? So that would be 68%. Okay? And we're doing a sample of 820 members. So do 0.68 times 820. Okay, I got 557.6. Or since they're talking about people, I just rounded up to 558 to have a whole person, not a point of a person. Yeah, I rounded up. Okay, then letter B, what is the probability that a random member will have more than 14 friends? So we need to go from 14 and beyond there. So we need this section, which is 13.5. Then we need these two sections. So those are each 34. Then again, 13.5. This one is 2.35. And then the last one is 0.15. And subtract from 100. Yep. Okay, so this would end up being 97.5%. Okay, so add up all the percents to the right there. Whereas Tegan said he just subtracted 100 by 2.35 and 0.15, and you get the same answer.